Hello. Today we are going to see most dangerous question of maximum minimum in application of derivatives chapter from class 12 Cbse. Let's quickly get into the question. So I have the question here. Prove that the volume of the largest cone that can be inscribed in a sphere of radius capital R is 8 by 27 volume of the sphere. All right. So I have the diagram with you and the disclaimer for this video. You may not be given the diagram as well. So you should be prepared to draw the diagram, mark the parts correctly. What I mean by the word correctly? The capital R is for the radius of the sphere. Don't swap the radii for cone as well as for sphere. It has to be properly named. Capital R is for radius of the sphere. Therefore, for small r, I'm considering it as radius for the cone. And recently, I saw in a paper, small r was for radius of the sphere. So go through the question very clearly. See, the question is just not even 2 lines, but there is so much information hidden in this question, and this is a very big question to be solved. So what are we supposed to prove? The keywords here. Prove the volume of the largest cone. So we have to prove it is maximum. That can be inscribed in a sphere of radius r. What does that mean? Capital R, it is fixed. R will take some numerical value, so it is not going to change. Now, what is the concept here? You're going to alter the cone in such a way that it has the maximum volume and it is 8 by 27 volume of the sphere. So what do I mean by saying that the cone has to be adjusted? You can reduce the small, you can reduce the R radius, increase the height, or you can do the reverse. You can reduce the height and increase the radius. However it is, the volume has to be largest. So I've taken the data here. Radius of the sphere marked as capital R, that is given in the question, and radius of the cone is small r, and I got a right triangle here from the diagram. So OBD is the right triangle. It is right angle at D. Therefore, we could form Pythagoras theorem from the small right triangle, which is present here. Now, AD is the height of the cone, which is marked as H, and OA is again radius of the sphere, which is capital R. They do not get confused with the parameters being used. Be very careful with the naming part. Therefore, I'm getting OD as H minus R. Hope that is clear from the diagram. Now, what is the Pythagoras theorem for this right triangle? H minus R the whole square plus R square is equal to capital R square. Hope this is clear. OB or capital R is the hypotenuse for the right triangle. So I got the Pythagoras theorem here. Let me expand this. H square plus R square minus 2RH plus R square is equal to capital R square. So the R square is getting cancelled. So I have R square is equal to 2RH minus HR square, transposing the other two values to the right. Now, why do I do this? We have to find the volume, the cone where it is largest. So we are going to find the volume, which is 1 by 3 pi R square. Radius of the cone is small r and H. So that's why I've got R square here in terms of the fixed radius R and the height H. So I'm going to use it here in the volume equation. In place of small r square, I'm going to replace this. So what happens here? V gets transformed to, I will write 5 by 3. In place of r square, it is 2RH minus h square multiplied by the height h. Now this is going to be the differentiation part because we're going to prove this volume to be maximum. What is the concept of maximum? First order will differentiate, equate it to 0. You will get the values of the variable, maybe 1 or 2 values for the variable. Then you will differentiate it again for second order, then replace the values that you received 1 by 1 in the second order. So if you are replacing and if you're getting the second order to be greater than 0, that is minima. If you're getting less than 0, it is maxima at that particular point. So let's do the differentiation here. dV by dH, because This is going to be with respect to h, as capital R is constant. So what happens here? Pi by 3. Now this becomes 2r h square when I bring this h inside, and it becomes h cube when you're multiplying h in both the terms. So this will be 2r h square. When you differentiate, it becomes 2r into h square. Differentiation is 2h minus h cube derivative is going to be 3h square. Hope we can understand this. It's just a single first order derivative of the given volume function. Now, I'm going to arrange this and equate it to 0. dv by dh is equal to 5 by 3 4rh minus 3h square. And the question goes like this. We are going to equate this to 0 to get the values of h. So 4rh will be equal to 3h square on equating this above equation to 0. So you can get rid of 1h by cancelling it. So h is equal to 4r3. This is the relation between height of the cone and radius of the sphere. All right, so we got this. Now, what are we supposed to do? We have to do the second order derivative and prove that the volume of the cone is largest. So we will differentiate this again, pi by 3 being constant. So I'm writing it here. D square V by dH square is pi by 3, and differentiation of 4RH will just be 4R as derivative of H is 1, and for 3H square it will be minus 6H. Okay, this is the second order. Now what are we supposed to do? Replace H by 4R by 3, which we just got by equating it to 0 in the first order derivative. So if you replace that, 5 by 3 into 4r minus 6 into 4r by 3. The value of h is 4r by 3. I'm just putting it here in place of h. So on solving this, I get 5 by 3 into 4r minus 8r. So if we cancel this, it will become 8r. And for sure, this is less than 0, because on solving this, you get minus 4r into 5 by 3, which is definitely going to be less than 0. Therefore, we have proved that the cone's volume is largest when h is equal to 4 by 3. Because when the second order is less than 0, that is the proof for maximum volume according to the question. Now, we have to prove that volume of the cone is 8 by 27 volume of the sphere. So, getting back to this equation, we're going to replace r square as this. We're going to replace h as 4r by 3 from this equation. So I'm going to replace both the values here. 1 by 3 pi into r square into h, right? Which is going to be 4r by 3. So I'm solving this here. This is pi by 3 2r into 4r by 3 minus 4r by 3 the whole square into 4r by 3. All right. So when we're going to simplify this, this changes to 5 by 3 to 8r square by 3 minus 16r square by 9 times 4r by 3. Hope we can understand this. So we've just squared this and simplified here. So I'm taking LCM here. This is going to be 3 times. So multiply this also with 3. So you get 24r square minus 16r square. So we get 5 by 3. 24 minus 16 is 8r square by 9 into 4r by 3, which is here outside the brackets. Now, on simplifying this further, we get 8 by 27, 8 by 27, 4 by 3 by r cubed. 8 by 27 into 4 by 3 by r cubed. This is a very interesting question, and this is how it's going to be solved. So we have first proved that the volume is maximum for the cone, and we also proved that in that case, volume of this cone is 8 by 27 volume of the sphere. Hope this is very clear with you all. Repeated practice is very important for this question. Do it multiple times, practice well. All the very best. See you all soon in another video.